Good afternoon to all of you. It's very happy to see you all here in the hall. And I will be handling a session on how we can really transform the manufacturing, especially for a short batch production like a UAV, and how additive manufacturing is going to help you out in making it happen. My name is Janardan. I work for Regington. Regington is the exclusive distributors for the HP range of products. So we are in this business for almost 15 years now with the various technologies, and we have really empowered a lot of startup companies to really build up a business around additive manufacturing. As an organization, it is basically a 12 billion, it's almost 1 lakh crore is our annual turnover, where we are the distributors for the major brands of IT and mobility solutions. And we have spread across almost 40 countries with more than 50,000 partners in India, dealing with our products and making it delivered to you, all of you. So here, we all understand what the startup community is looking at. So basically, they are looking at how they can run the business with a lower investment, because finance and funding is the biggest challenge for them. And most of them spend a lot of money in developing the product, spend a lot of money on R&D, and when it comes to a production stage, that is where they really struggle to really generate money, because they might have taken 2 years, 3 years, 4 years to really develop a product, and they should have spent almost everything what they had from the initial venture capitals and everything, or whatever funding they have earlier, and they'll find it very difficult to really manage the production or set up a production. That is when they think about, how can I generate fund from the market? And if you just get into the market with your technology, which is not proven, which is not being started manufacturing, and after a tenure of long time without any revenue and only for spending for R&D, it is very difficult for them to get a good valuation for them, and they find it very difficult to really start up and get into the market with their products at a shorter time. Second thing is, competition is there. There are a lot of startups working on same areas, and faster I bring my product into the market, I can be a leading brand in the market. So always there is a pressure of time to market, and again, when you speak about the production, they want to make to be competitive in the market, and how can I make my product more competitive, how can I reduce my overheads in production, and how can I bring it into the market at a lower cost and be a competitive cost. And another factor which most of them really is worried about is my design complete? Is my product what the industry is looking for? Or the expectations of the industry is much more than what I have done it so far? How much of improvisation, how much of customization, how much of product redesign is required to really bring it as a cost-effective as well as a competitive product in the market? So all these challenges really come into that, and most of them doesn't know what is the market ahead of them. So when they don't know what is the market ahead of them and what is the revenue stream which is assured for them, it will be more and more challenging to really create a business plan and really get a funding for starting up a production environment. So with these challenges, almost all the startups are struggling to really have a plan ahead. And when their production volume is very low, or probably the product demands, or product is more of an advanced technology product and the volume of production is very low, then again the manufacturing, how to manufacture that and get into the market will become a total confusion for all of them. So what we are speaking about is, I think we have some good sessions in the morning. Those who attended the morning session, they might have got a deeper depth into the areas where we can really assist you in design and development. Mr. Gino and Daniel have spoken about that in the morning. And after that, I think in the afternoon, Surup Chand also has spoken about it. So what we are looking at is basically how we can approach the manufacturing of our products through a strategy or through a proper strategy where we will be able to really make it as cost effective. Most of us know that 3D printing is available for years together, more than 3 decades. And we had seen the evolution of that with multiple technologies. We have seen that with multiple applications. They also started focusing on specific verticals. And we had seen a lot of development happening in the medical equipment, or probably medical implants, or probably on the aerospace, where there is a little bit of production happening using 3D printers. But if you look at the industrial or automotive industry, still people always think about designing for injection molding or any other alternate conventional manufacturing process rather than getting into an additive phase. The major reason why behind it is basically because the primitive 3D printers which they started using or they are aware of was not capable of really creating the profit, cost efficiency, nor reach the production volume which they wanted to really develop. But today, the things have been getting changed, and we are also companies like HP has brought up 3D printers, which is basically focusing on production and how we can make it happen through that. So I'm not going to speak about the HP machine, or I'm not speaking about that. What I'm trying to speak about is basically how we can address challenges and what are the kind of solutions what we have in additive manufacturing which can do that. So the key takeaway is to how I can address my challenges, which I explained in the previous slide, as well as how to focus on developing a product for performance rather than manufacturability. Most of us know that every manufacturing process will have its own challenges, its own limitations, and we have to follow some standard procedures to really achieve that. But when you look at additive manufacturing, things are not different. It is the same way. We need to, if we want to really make a product cost effective in additive manufacturing, we have to make sure that we follow certain procedures, and we have to really do some design modifications according to that. So when you come into a prototyping environment, most of us know that we will think about manufacturing in injection molding or some other alternate conventional process, and we do a development of the product based on that design parameters. And finally, we want to take a prototype and get it into, use additive manufacturing for that, for the faster manufacturing process without much investment on tooling. And finally, we will say additive manufacturing is very expensive, and we will not be able to afford that. But that is not the real case. There are ways and means where we can really make your design cost effective, performance oriented, and can be designed with any manufacturing constraints. So designing for manufacturability is the biggest challenge which the designers are facing today. And we are here to address that. You start designing it for performance. Second thing is design freedom what you get for the engineers. When you are designing for performance, you can have all your innovations, all your thinking put onto the design, and you can design whatever geometry or whatever way you want to do it. And finally, when we speak about manufacturability, I think we can have overheads, undercuts, molding might be difficult for you. We can print assemblies. All these things are possible for you. So if we want to implement all these things, we have to approach this adoption of additive manufacturing in a strategic way, in a standard process. We cannot take this design of additive manufacturing or adoption of additive manufacturing as an experiment. It has to be a process, and it has to be a strategy for you. So when you go through the life cycle, today if you look at, we might be using additive manufacturing in the initial phase of concept modeling as well as for the design development. Can we deploy additive manufacturing in the next phase of manufacturing? I will say yes, and I will say no also. Mainly because if you are looking at a volume manufacturing, conventional way of injection molding or alternate ways might be much more cost economical for you. But if you are in an industry where you have limited volumes of sales, or say hundreds or thousands or 10,000 or 50,000, that is where this additive manufacturing can help you out. Can I additive manufacture all the parts? will it be cost effective? I would say no. Mainly because it all depends on your geometry, it all depends on the complexity of the design. But one thing I can assure you is that more complex the part is or a geometry is, you will have the cost economics will be much more better for that. Mainly because you will have to spend more money for tooling, and when you really amortize that tooling cost for the number of parts you are going to manufacture, additive manufacturing can add value for you. So it all depends on the design, it all depends on the geometry, and it also depends on the number of parts you are anticipating for the design. So if all these things, parameters are coming right, additive manufacturing can be cost effective for you. So especially if you look at the drone industry, we all see that there is a lot of development happening, there is a lot of applications are getting deployed for the drones. Each and every order or each and every application what you are speaking about is totally different from the other. So the same design which I am doing it for one drone cannot be common for all my applications or all the drones which I manufacture. Each and every order of a drone or a contract for a drone might be different from the other, and it may demand design changes or improvisation on your current design. So when this is the situation when you are facing, I can tell you 100% additive manufacturing can add a lot of value for you in your manufacturing process. So we are very focused. We want to make sure that we take applications which need these 4 parameters. One thing is where design is more of personalized, or we need a lot of customization on the design, or there is a continuous improvement happening continuously on that job. If that is the condition for you, additive manufacturing can be the best method for you to really rely on for manufacturing. Second thing is the toolless manufacturing. If I really don't want to invest money on tooling, spend money on tooling, if the market is indefinite for me, or I don't have that much of finance to really do that, and if you want a part to be, if you are non-dependent, the production cost is non-dependent on MOQ, because always the tooling, the production cost will depend on the number of parts you are manufacturing out of the tool. But here, one part you are taking, 10 parts you are taking, 100 parts, 10,000 parts, the product cost is going to be same for you. So it means that you will be able to really optimize your costing, you will be able to plan your costing much more better, and MOQ will not be a dependent factor for your challenges. Third thing is the low series production. If a product is of low series of production, or if there are some standard parts which needs volume of production, you can always rely on conventional manufacturing. But there might be certain components in your drones or any of the equipment where there is a product variant happening, and every design may need that part to be of different design, depending on the payload or whatever factors it depends on. If there are certain standard parts which will be in volume, there are certain parts which is going to change the design on a very order or customization is required. In that area, what you can do is, you can think about manufacturing the standard components in the way you want to do it in an economical way, because you know there is a definite volume for that. But if you look at the non-standard part, you can always rely on additive manufacturing, so that the design is, any change in the design can be accommodated in the next batch of production. And again, MRO. MRO, it can be on-demand manufacturing. Even the manufacturing of each and every component which we do it on additive manufacturing, it always can be on demand. You don't have to keep any inventory. And it is becoming the additive manufacturing process is becoming faster and faster, and we are able to deliver the part within 24 hours with the production. So it means that on-demand manufacturing and reduced inventory also can be a good component which brings in cost efficiency for your operations. Here I am speaking about, if we want to really rely on toolless manufacturing, using additive manufacturing, first thing you have to do is, you have to think about that during the initial conceptualization of the product. If you have complete your design and then you feel that injection molding is not going to help me out and I want to rely on additive manufacturing, then you may have to rework on the design. Otherwise, it will not bring you cost efficiency. So if you want to adopt something new or if you want to adapt getting into additive manufacturing, please think about that during the initial phase of the project and start designing the product with a new perspective, not with the thinking of how you do it for injection molding. For example, I think Gino was very vocal in speaking about that for almost 2 hours, how the design changes in of a product can bring in cost efficiency for you. How can it make it lightweight? And how can I make it split into different parts and assemble together using snap fits, and how I can really do assembly much more faster without any fasteners. So all these topics are basically come to one point where when you are looking at toolless manufacturing, please start thinking about design innovations and bringing that innovations into that. So I'm not taking an example from a down industry today as an illustration. The concept of design for additive manufacturing, DFAM, is a very important factor when you decide that your product is going to get manufactured using additive manufacturing. The first example on the right, on the top, is basically when an injection molded part is getting designed for additive manufacturing. First thing I'm going to do is, I don't want to have 10 parts in my assembly. I want to reduce as much parts as short as possible, and I want to make sure that there is a part consolidation happening there. So when I'm doing a part consolidation, the benefits what you are getting it is the failure rate, the higher performance, lesser failure rate, higher performance, cost efficiency. And when you consider compare the cost efficiency between additive manufacturing design and injection mold design, you may have to make 10 to manufacturing tools, column cavities, if I want to manufacture 10 parts in injection molding. But here, we are not spending anything for the tooling. We might be spending slightly higher for manufacturing these components, but when I amortize the tool cost against the volume of production, additive manufacturing can be much more beneficial for you. I think in the morning session, we have seen a lot of parts where the part consolidation was happening on the designs. And second, about the generative design. The second middle one is a generative design. It is basically a gripper for a robotic arm. Just see the geometry. And I cannot think any other manufacturing process other than additive manufacturing for this kind of a design. The advantage what I am getting it is, I am minimizing the material usage. I am getting an optimal design for the performance as well as sustainability of environment. If I want to machine it or if I want to do injection molding, I will be using more material. I will be removing lower material. Always the part will be over-designed. When the part is over-designed, it will be of higher weight. All these challenges comes in when you are going for a conventional manufacturing of this kind of geometry. And most of the time, that geometry may not be manufacturable in a conventional manufacturing. Here in this case, whatever be the complex geometry, I will be able to manufacture in additive manufacturing. Third is, again, a part consolidation. Just see, aluminum parts are getting converted into polymer parts. And when you are going machining of an aluminum part, there are multiple limitations for that. I have to check whether I can do it in a 3-axis machine or a 5-axis machine. I wanted to check whether the tool can go into that area and do the machining of that. If the curvature, what I want, can I get it machined out of CNC machines? So when I think about converting that, I am consolidating the part, I am redesigning it for performance. Also, I am bringing in generative design into the topic, on the part. So all three combined together, I am getting cost efficiency in each and every operations what I am doing on that part. It means that the design is going to perform the way I want it. I am getting a geometry which I really want, I have designed. At the same time, I am able to match the costing what I am expecting out of it. So if you are able to spend your time, if you are able to decide that I am going to bring design changes, I am going to bring designed for additive manufacturing during the initial phase of your project. And when you start designing it with that in your mind, I'm 100% sure most of the designs which you are doing it will have a sea of difference in performance, in cost efficiency, and the sustainability in the market. So our engagement, if you look at HP or Regington as a company, our engagement is to engage with you from the initial phase of concept design and take you to the manufacturing through consultancy, through assistance. We can do proof of concept. So if you look at the drone industry, we have done a lot of work during the initial phases, during concept design, and we have given prototypes to them. These prototypes were tested by them. Then when they go for certification, they go with the manufacturing process of HP for certification. And once the product is certified, they rely on HP machines for manufacturing it. So we can go through the complete cycle. We can help you to and give you directions how you can optimize your design and make it adaptable for additive manufacturing. I think this example was discussed in detail in the morning session. This is one of the, because most of the designs which we get, that comes under NDA. So we will not be able to really take it for the presentations of this kind. But this is something which we got it approval to really present it. So that is the reason why both of us are repeating that. This is an Indian example where this company started designing for additive manufacturing, brought all the innovations on their product using additive manufacturing, and we are really serving, we are manufacturing. They don't have a machine to manufacture it. We have an ecosystem where this manufacturing is happening. I'll come to that later. So the product looks like this. This is the machine which manufactures. And it has got the productivity what you really want for a series of serial production. We are bothered about the quality. We have our own standard procedures to really maintain the quality. And I'm 100% sure because of the throughput which this machine can give you, and because of the productivity this machine can give you, because of the modular design, because of the time taken for printing, because of the material consumption, because of recyclability, all these factors are influencing the cost efficiency of this machine. So if you are designing a product for additive manufacturing, and if you are really optimizing the design for printing on our product, we can assure you that you will be able to get right cost efficiency in your manufacturing. Remember, the MOQ, whatever be the MOQ, there will be a consistency in your production cost. So this is basically a powder-based technology, and we are not using any laser. It's a non-laser-based technology, and we have certain chemical agents which will get jetted on the powder bed, and that enables that area to get fused. And don't think that you might be fusing only 5%, 7% of your powder, but I can reuse that powder for the next job. I will be slightly adding some little bit of new powder depending on the material which I have, or different brands of material, or different categories of material, and I will be able to reuse that material, bringing sustainability again on that, and I will be able to print the parts using this technology. And this, I can assure you, this technology can bring you a part which is as good as your injection molding in terms of strength and mechanical properties for the specific material. And we have a range of materials also which these machines can print. We can print in PA12, which is basically most commonly used one in the drone industry. We also have PPs and P11, TPU. You name it, we have much more material on that. And the way we manufacture, we are not manufacturing one part at a time. We are nesting these parts. We are creating a cluster of these parts and printing it in one go. And the printing time will be constant, irrespective of number of parts you are able to accommodate in the given volume. So we can produce parts in volume, and more parts you are embedded on one job, the cost of production per part will be much more lesser compared to lesser stuffing. So if you have 8% of the volume is getting fused, if you have 10% of the volume getting fused, 10% volume will be half the cost of your 5% utilization of the machine. So if you look at how we at HP and Regington, how our solutions is getting adapted to manufacturing, one is we have the predictability of time, the delivery time. because irrespective of number of parts, the printing time is going to be constant. High productivity and throughput will enable you to get these parts at a lower cost. And end of the day, so when you want to invest on production, if you want to invest on a tooling, you have to spend your money, get the tool done, and then start the production. Here in this case, without investing a single penny, you will be able to get these parts manufactured in India, because we have a network of partners ecosystem available across the country, where these people has bought the machines to serve people like you. You can send your designs to them. They will tell you if some design changes need to be done to optimize it. You get the design changes done, make it cost effective, ask them to print and deliver to you. They will do that for you. So it means that without spending your investment or without any single rupee investment on tools or equipment, you will be able to manufacture these parts and get it at your doorstep. That is a service we would like to offer, and that is the service we are offering for the community. So we are all concerned about the financial pressure you all having during your process, and this is the way we can help you out to come out of that issues. Thank you very much. This is my concluding slide. We want each and every designer in the startup community for design for performance. Don't think about standardization. Bring in as much as customization, personalization as required to make your product much more competitive, much more efficient, much more performance oriented. The time has gone where you can have the heavy parts, over-designed parts in the industry. You have to think about lightweighting. You have to think about design optimization to bring and make the utilization of the material as less as possible, so that it will be covering the sustainability targets of the country also. And designer will have the freedom to work. They will have the freedom to design their components from the imagination. There will not be any manufacturing constraints for you. You can keep designing the way you want it, keeping performance as the sole objective of your design. Thank you very much. I will be reachable in this address. You can really send me the email. I will be available here also. And we have a stall also in the drone area, Regington HP stall. You will be able to visit. You will be able to really feel the parts. We have kept some parts for display. And we can also have a discussion with the experts over there. We have a team of people already available there. So on the way back, I think you can visit our stall and have a look at these products and really get familiarized with the technology. Thank you very much for the opportunity, and thank you very much for attending this session. Thank you.